All right. Hello, everybody. Thanks for hopping on today's TAP session. For anyone new, TAP stands for the Trusted Advisor Program. It's hosted by the Cisco Philadelphia Select Team, where we bring the latest and greatest from Cisco. There's just a lot of tech going on right now, and it's hard to keep tabs on everything, and a lot of it's dependent on what's going on in your infrastructure. So our goal is to break down what's new, what's relevant, and what's going to make a difference for you and your business. Today, we're diving into Cisco's SSE offering, which is secure access. With more users, devices, apps, and data to manage than ever before, not to mention the rapid shift of remote and hybrid work, it's obvious like the old school methods just aren't holding up. That's exactly why so many IT and security teams are making the jump from traditional decentralized setups to centralized cloud-based solutions. We're joined today by James Cox, a solution engineer who focuses on all things security here at Cisco. He'll walk us through what this shift means for you, your teams, and your overall security approach. James, thanks for being here.
Yeah, absolutely. Appreciate everyone joining today. Again, James Cox, Technical Solutions Architect, Systems Engineer for Cybersecurity. I'm here covering the entire Philadelphia Select region. I see some names in the panel or in the attendee list that we've chatted with before. I appreciate everyone joining. Going to share some content here with everyone today, and if time allows, we'll actually look at a live demo of secure access. But secure access for us in Cisco is a newer product, but it is built on technologies that we have been using for decades at this point. When we talk about kind of the complexities of remote access, and we talk about frustrations that customers are bringing to us as an organization. We understand that it is getting more and more complex. We are seeing the number of organizations reporting more issues with remote access VPN, whether it's from a provisioning perspective or from a usage. And we understand that there are gaps in coverage where we are not seeing full visibility into our traffic when our users are accessing resources outside of traditional RA VPN type scenarios. And again, we've kind of heard this. We've heard what our customers are saying, and we are seeing the customer base out there is saying, "Hey, we're seeing a lot of risks inside of our VPN architecture. We're seeing multiple different dashboards we have to manage to try to achieve a visibility for all this complexity." And from an end user perspective, we're seeing frustrations from them that they are unable to understand where and when they need to connect to remote resources and what those appropriate ways to do it, those connections are. So with that, we have introduced this product called Cisco Secure Access. And with Secure Access, we are leveraging a lot of our legacy style products that we have been using for decades. With Secure Access, this platform is a cloud-hosted RA VPN plus SSE solution that we've taken a lot of our core product lineup from what we would consider a traditional edge-based VPN scenario, or a cloud-based umbrella DNS-style protections, and put it all into one cloud. So we've layered in a bunch of our product sets into this application. We've created this for a myriad of reasons, right? Every one of these before was different consoles. So today we have single consoles. While not so much different clients per se over the past, for all these integrations, there were different ways to access them. We now have a single client for this, as well as the idea that in a traditional RA VPN, we would create a VPN policy on an ASA or an FTD. We would create a DNS policy in Umbrella. We would create a CASB policy somewhere else as well. And now we actually have the ability to create these all in one unified policy set. So we're not jumping between different platforms to achieve remote access VPN or secure remote access VPN and visibility. A lot of what we're going to talk about today are going to fall into two buckets. We label secure access as secure internet access and secure private access, and a couple definitions around that we want to clarify. Secure internet access is going to be our DNS style approach, our SWG Secure Web Gateway from the Umbrella side of things. And our secure private access is going to be leveraging things like RAVPN as a service, as well as zero trust network access, where we're actually not having to do a full IPsec tunnel to sites and to services. So again, just clearing up a couple definitions there you may hear me mention as we move forward. Kind of highlighted this in one of the first slides, right? There is a big challenge out there in the newer hybrid work ideas, right? Our users are used to being inside of an office where they open up their laptop, they log in, and they get access to the applications or services internally to the data center. Now that landscape is changing. There's more challenges with that with a remote worker, they may not know when they need a VPN in. They may not know when they need to provide or when they should be providing MFA. They should be providing MFA for everything. And our goals here are to simplify this. So from an end user perspective, we're going to start showing in a couple slides here, we'll show how the end users are connecting to this. And from a network operations perspective, how we're getting visibility into these style connections. Our goals are very simple inside of secure access. We want to connect any type of user, any type of device, whether it's a branch office, a remote office, or just a user that is working at Starbucks, to anything inside of your environment. And anything inside the environment can be defined as inside your physical data center, out to third-party SaaS applications like things hosted in AWS and Azure, or just let's say ServiceNow or other things behind CDNs, as well as giving visibility to just regular internet sites. Sorry,
And the one thing that the one thing I like to add to that is also you're getting out of hairpinning. Like you're not hairpinning back on-prem to go to an app that's already moved to the cloud. So you're alleviating some of that stress on the data center, but you're also just giving them a more direct path.
Exactly. So again, talked about this in just a previous slide, right? Our goals here are that our experience for our users is the same whether they're on or off network. They open up the laptop, they log in, and they start to work. The secure access cloud will determine where and when to send the traffic that we're seeing to, whether it's a zero trust network application, like a private app inside your data center. We need a full-fledged tunnel for this. We will prompt them to spin that up, or again, just going out direct internet access or out to a third party. But the goal here is that the end user doesn't need to know when to use these different methodologies. The secure access cloud will figure that out for them. Again, we have leveraged a lot of our core technologies that we've developed for years and years and years into secure access. The core basis of secure access is Umbrella. This is going to be living in the same data centers and the same AWS regions throughout the world that that Umbrella is hosted in, as well as leveraging and layering in things like advanced malware protection. So as we see files move across the platform, we will do inspection of them. We'll look at things like DLP, and we'll actually talk about that a little bit in depth here in a second, as well as the idea that we're bringing in IPS IDS as a full-fledged firewall perspective. So now I can create rules around the traffic we're seeing that have full layer 3 through 7 capabilities to them, and not just being limited to saying, hey, we're only going to block SSH or we're only going to allow HTTPS. I can now get granular and say, we're going to allow a SQL developer to contact the SQL servers they need to on the specific ports and protocols. I will mention...
How would access be for vendors accessing the company resources currently through AnyConnect client and DAP policies controlling their access?
Yeah, so we have a couple different approaches to that, and I will touch on that in maybe 3 slides from here. So there are a myriad of ways that users, whether they are company users or they are contractor style users, can access secure access and get access to designated resources. So it's no longer just an open policy that allows them to contact anything inside your data center or cloud providers for that matter. So I'll hold that question just for a second, and we'll circle back to that one. But great question. And this is actually where we'll start chatting about some of this. So again, we're talking about a couple things here inside of secure access. We're talking about users or devices and how they can connect to resources inside your data center or outside in, again, private and public clouds. And I'm going to layer one more piece of this in here that we can actually talk about SD-WAN as well inside of here. But, and probably to that question, we'll have one more slide here in a second and we'll explain a little bit more. But in that use case, right, we talk about contractors. Contractors could come in a myriad of ways. They could come in as a client-based with secure client, or they could technically come in with client lists. And from a client list perspective, we can publish DNS records for your apps and services that will be routed up into secure access itself. Goes through all the pieces in the middle here, which is what we refer to as a policy router. Gets all the appropriate allows or denies added to it, and then obviously the final connection back to the data center, back to the cloud resources. But what I want to pause there is, again, our end users, we have a couple of different ways we can make those connections: clientless, or IPsec tunnels. So you could connect your remote offices to the secure access cloud. Once we go through all the policy side of things, we create a couple different ways to access those applications all the way on the right. The first one that we would actually deploy is an IPsec tunnel. A note on these IPsec tunnels: these are not vendor specific. So as long as the endpoints support IPsec, we can create connectivity to them. So if it happens to be a checkpoint or a Palo style firewall, we can create that VPN IPsec tunnel to those services. We also have the ability to do this idea around when we talk about cloud hosted through AWS and Azure, using an API based connection, so we don't have to have a VPN tunnel spun up at all times. So again, our users come in from the left hand side. We touch all these different pieces of the policy, whether it is just looking at the overall posture of the device. We know that it's a Windows 11 machine. We see that it has certificates enabled. We know that the user is enrolled into MFA, and MFA is transparent here. It's not specific to any major IDP. We will play nice with all the major providers out there. If the user's just going out to general internet resources, we'll push them up to this top tier here with DNS security, with all the traditional rules and functionality of Umbrella inside of it. And then again, if they need to access something through a VPN tunnel, we're going to look at exactly where they're going, look at the rule sets that are trying to be applied to that, so that we can actually get very granular in saying you can only, contractor A can only get access to servers X, Y, and Z on port 22, right? SSH. Or you can only do RDP if you're not following, you don't meet some of these criterias. So we get very granular policy inside of this, and the ability to build that out again, so that our VPN tunnels, which could be traditionally just allow any access into the data center, are only allowed into certain applications and subsets of applications. So with that, right, we did talk that this is from a VPN perspective. In the back end, we can play with a bunch of different third-party style VPNs. But on the front end, for our end users, we are going to leverage Secure Client, or as you may refer to it as AnyConnect, as the older version. Secure Client has evolved over the years. Secure Client is no longer just a VPN tool, right? The core of it is absolutely VPN, but now we've layered in different modules inside of here that these are not separate applications. These are not separate EXEs. These are modules inside of the application that we can turn on and turn off for different use cases. This example here is actually with everything visually represented. So we have our general VPN core module, which is our standard. We can type in vpn.company.com, hit connect, we'll be prompted for username and password. We then have this idea of zero trust, right? Where we're making point in time connections based on a policy that says, here's a bunch of resources that will allow to be zero trust enabled. And when we see those style connections, there's no interaction from the user, right? We create a tunnel point in time from the client to the service. And when that connection is done, we spin that back down. So if a user is accessing an application, an internal style application, and they're on the road, they open up the laptop. We know they've authenticated, they've done all the MFA checks, the laptop is good. We're just going to grant them access to the application. They don't need to spin up the VPN tunnel to get access to it. We'll show a couple examples here in a second. We do have the ability to have the module for our secure endpoint, our EDR solution. Not required for any of this, but it is a module inside of here. And then we do have our traditional roaming module or the umbrella module included. You will see a couple of notes in here that Thousand Eyes is integrated, and we'll talk about that in a little bit, as well as the idea that we have a client management module inside of it. So when we look back and we look at how Secure Client or AnyConnect was managed before, we put it on the head end of our firewalls, whether ASA or FTD. We push updates through that. We push policy through that. With this being a cloud-hosted solution, we still do the same. We actually give you a console, a cloud-hosted console, where you can go in there and pick and choose different policies or profiles to be associated with different users and different groups. You can control what versions of the modules you allow. So from a CMDB perspective, from a change control perspective, we give you a ton of controls to say, hey, we don't want to run the latest and greatest if we don't have to. We want to run a version that's 2 or 3 versions back. That's fine, right? There's nothing wrong with that. But now, again, where you had that granular control in the firewalls themselves, when we shift this out, we now give you the cloud-based version of that to do those same features. And lastly, there's always going to be diagnostics and reporting inside of this. So from a troubleshoot perspective.
Do we have the ability to differentiate access between vendors and company employees when it comes down to pushing out policies, like only push out umbrella module to company employees and not vendors and contractors?
Yes, we do. So inside of the secure client management module and web interface, we actually have the ability to break that down into different profiles. So the profile will be for internal employees. They would get different settings, as well as the contractor role may not need the umbrella feature, so we can actually turn that module off. And our goal really with a lot of this is actually, if we can get everything over into ZTNA, we can go ahead and turn off that VPN core. So if you have a contractor that's accessing a service that can be done via ZTNA, we don't even need to give them the ability to try to spin up a VPN, a standard IPsec VPN tunnel.
Okay, so in short, it would be if the application is hosted in the data center, you may still need that VPN access, but if it's hosted elsewhere, you can probably use ZTNA.
ZTNA can still be used for data center applications. Yeah.
Okay.
So it's just a methodology of trying to present that application to the user. And we'll talk about some pros and cons here in actually this next slide. So again, ZTNA is kind of a newer idea for us in the way that we handle it. With our traditional VPN style connectivity, right? This is everything that we've come to know and love with the traditional ASAs and the FTDs. All right, we can do SAML, we can do certificates, we can do posture checks based on what we see installed on the box. They don't meet them, right? We want to allow them on the network. We take that one step further and we actually talk about the ZTNA style module that's in there. Again, these are point-in-time tunnels, and we do that through Quick, and we actually do it through a mask proxy. When the user is first enrolled into the ZTNA, we push a certificate down from the Secure Access Cloud. That certificate is set up there to auto-renew, and as long as that user is still enrolled, they're still part of the company, they'll be allowed to access those resources or get that certificate updated. We do allow SAML authentication in this module itself. It makes it for an easy enrollment. And one of the things to kind of talk about here really quickly is when we talk about ZTNA using Quick and Mask, we can actually see TTL performance increases compared to our traditional VPN style connectivity. So we're not having to encapsulate that into IPsec because we're using Quick. And we can actually see performances of 30 milliseconds depending on where they're trying to get to around the world. that we're not creating that overhead, right? We're not creating that additional latency inside of the application. Again, the goal: the user doesn't know if they're on the network physically in your office or not. We also talked about the idea that this still has everything as far as the umbrella side. So there is the web module inside of here. This is just going to specifically look at 80 and 443. And the goal, or the end case there, is that it's going to be going out direct internet at that point. And again, I mentioned the idea that we have this client list side too. We publish some URLs, some DNS records for you guys. When those DNS records are hit, it's being sent up to secure access. And then based on what we know about the user that's trying to come in, the endpoint that's trying to come in, and when I say user and endpoint, this could be geolocation, this could be time of day. So if you don't want users accessing an application after hours, that in that methodology, we can restrict it. But specifically in this client list, this is web apps, right? So this is not going to be every port and protocol like the ZTNA module is, or the traditional VPN module by itself. I'll pause there just for a second to get a sip of water and ask if there were any other questions that popped up.
Yes. So we use Citrix for our contractors so they can access resources through Citrix published apps. How would this solution fit?
Yeah, so it could fit a couple ways. So it could fit from a client list perspective, where we're banking on Citrix doing all the additional checks and balances. So the end user would go to citrix.company.com, which is routed up into secure access. Based on that we don't know much to it, we'll have a rule that says yes, you can hit the front end to the Citrix appliances or servers in your data center or in your cloud. And then based on the fact that you have other security mechanisms there, again, secure access will process that traffic, pass it on, and then they will get prompted for a log on at that application. If we take that back to a ZTNA perspective, we can actually do all the authentication pieces in the front. So when we see the user log into the system, into a managed client, they would just launch the Citrix application on their laptop and get to work just as normally as they would if they were in the office. So we can present that application. We can present any port, any protocol, TCP, UDP from a ZTNA perspective. So again, you are able to use those kind of use cases, and even into like a VMware Horizon or an RDP style solution, remote desktop as a service type solution. You can use ZTNA or the client list for that, as long as they are in that web app style space for the client list. But yeah, this could broker those connections, right? This could be that entry path. They come up to secure access. They hit Citrix, and then they go down into your data center or into your private cloud, wherever that's hosted. And we can, with those style questions, we can definitely, kind of work those out from an example use case perspective, as well as what the policy looks like. So I'd be more than happy to have some follow-ups around that to show that exact scenario. Anything else out there, Eric?
We're good.
All right. So
and that's actually one of my people, so we can take that offline.
Not a problem. Get in it. I want to actually go into some of these a little bit more detail around, and just for a couple minutes here, around what these the workflows look like. So this is our traditional VPN style connectivity. Our clients on the left hand side, we immediately do the authentication. We talk about MFA and posture. These are not required, obviously recommended. We pass everything through an L3, L4 firewall, so we can create those rules that say, hey, you're only allowed to 80 and 443, or you're allowed to RDP, or what have you. And then we route that traffic to wherever the resource they're trying to access is, again, being out in your AWS Azure environments or into your physical data centers. While this is only showing 2 connections at this point for this example, this can scale out, right? If you have multiple data centers, if you have multiple public and private clouds, we'll create that connectivity, and the services router or the policy router inside of secure access will handle that and send that out the correct locations. Um, being that this is a globally accessible application, this is one thing to talk about inside of the VPN side. So today, if you have multiple head ends for VPN in your data centers, you may have VPN1 and VPN2.company.com. With secure access, it is one URL. So it's just vpn.company.com. Based off of any cast, we will send that user to the closest secure access data center to them. Whether they're here in the US, they are European based, they will find the closest resource or closest POP to them. So they're not having to transit all the way back to the US to then transit back to Europe to get access to a resource that's hosted locally to them. So again, we are increasing efficiencies here where we're not having to increase latency just to come, to do that, as Eric mentioned before, to do a hairpin to come back. And again, this is all of our kind of traditional VPN style approaches here. What else did I want to talk about in this one? We're going to talk about posture in a second, so I'll leave that one up there.
Well, real quick, does anybody have? Can you go back a slide?
Yeah, absolutely.
Does anybody have any questions on this slide here? Just want to do a check in with everybody. All right. Yeah. Oh, yeah, we're good.
Good. Okay. So why I like to bring in some of these additional slides here is with a on-prem style VPN solution, you would traditionally have a radius control inside of it, right? For that authentication. Yeah, you can do it on box, but generally we're going to see a secondary radius. Hopefully it's with ICE, but it could be Microsoft radius style approach as well. With secure access, we can actually create the connectivity back to your current ICE environments, so that we can actually use ICE as the identity source to make sure that we understand who the users are, what the machines that they're using are, as well as do some posture and profiling checks around those users coming in. So we do need a connection, a VPN IPsec tunnel from your data center to secure access to make this work. In the future states, there will be some APIs that will allow us to happen without that. But for now, if you host this in your physical data centers or in your cloud instances, as long as we have that connectivity built out, we can leverage ICE for identity in the authentications. This is really calling it out for VPN as a service, but we can leverage it into the ZTNA side as well. And again, one of the things hopefully we'll get a couple minutes here to show when we actually look at client authentication, we will get a bunch of details of where we're getting that from, as well as the ability to do dynamic ACLs, change of authorizations, everything that ICE is kind of known for. We'll be able to push that back to an endpoint, apply policy based on those results, and again, try to limit down where those users are connecting to without, I say, reinventing the wheel, because if you're using ICE today for the radius connections, you probably have a myriad of policies behind it. So we can take advantage of those that are already designed. I'm going to build this slide out here. Okay, so Zero Trust Network Access, the ZTNA side. Again, I talked about the idea that we have the ability to publish applications from things all the way on the right-hand side to the users on the left. Again, we're doing this via mask proxy. We host the ZTNA client head end, the mask server itself. So when a client comes in, we first look to see are we hosting it? Are we trying to present that application to the end user? Once we know we're doing that, so app 1, app 2, we're going to do authentication against it. We're going to do, we're going to look at the machine, make sure it has it cert enrolled, that the user's valid, and that we're doing all these checks and balances. Again, we can layer in additional MFA. So if you say, hey, this application has to have MFA in front of it, we'll present that user with an MFA prompt. Again, not vendor specific. We support SAML throughout the entire MFA process. So as long as it's SAML supported, more than likely we're going to be able to integrate with it and do those additional MFA checks if needed. And again, we can also look at some posture and health. We'll see in the next slide here. When we're going through the ZTNA side, we step through the same firewall, so we can create those same restrictions on applications that If it's today it's IP any, and we only need it to be 443 and RDP, we can limit that down. We will then send the application or the traffic out to the data center where it's hosted. So in this example, it is hosted in 2 different data centers. App 1 is in the primary, App 2 is in the secondary. We will route that appropriately and not have to leverage your backhaul connectivity to get between those 2 data centers. We can do that if you need to, but traditionally we like to make those connections direct to those applications or to those data centers themselves. A couple things to call out here, and this actually applies to the VPN side. When we talk about routing inside of secure access, we can do it from a static route perspective where we say this application is only available in one location, or we can actually go out and utilize BGP routes to integrate into the rest of your network and route that traffic more appropriately for failures, for latency reasons. So we do have the ability to ingest BGP into here as well. And all right, go back one. There we go. We talked about this idea again. A lot of these look very similar from a client list perspective. Again, this is a use case where we are publishing a DNS record for the application. When we see that come in, we immediately try to authenticate the user. So in this scenario, the user will have interaction. They will have to prompt for username and password, and hopefully MFA behind it, because we don't want people coming in that can only provide username and password. We then go through a different piece of this. We actually go through the ZTNA proxy that we just saw a second ago through our services router. So if we see anything that they're trying to access different ports, different protocols, we'll deny the traffic at that point, as well as passing it through the firewall itself. So the use case around this, we heard one example of it of being contractor. This could also be BYOD. So this could be an internal use case where folks are using tablets or mobile devices to access a resource, and could be personally owned, could be company sponsored. So again, we have the ability to bring this in here. Again, this is all SAML authenticated. So as long as we can handle the SAML authentications, the application would present and pass through that SAML. There would only be that one authentication check in the first part of the connection here.
Or HR apps that you want them to be publicly accessible for your employees.
Yep. Yeah, it could be HR apps. It could be, things like Workday and Salesforce and ADP, for that example. Any questions around any of that? Thoughts? If anything comes up, please just put it in the chat. So I've talked about a couple different times in here around posture, right? And how we can look at the devices. We talked about the idea we can use ICE, but if we look back in time, we actually can do posture checks on the FTDs and the ASAs at a very high level, but we can still go in there and look, and we can say, is the operating system up to date? Do we have an EDR in there? And now we can actually start going in and saying, hey, do you have the firewall turned on? Is your disk encrypted? Are you running the latest browsers? And with each one of these different methodologies of connections, we can layer in different pieces here. So with a full VPN IPsec tunnel, we get a bunch more checks we can do because we can actually leverage looking into the operating system, right? We can look into the C drive of the machine or the Mac OS file structure, right? We can look for these pieces. When we talk about ZTNA, yeah, we lose a couple bits, but we actually gain one in system password, so we can make sure that from a disk encryption perspective, and we also have a system password on there. So if the machine gets lost, we know, hey, there is something out there that we can try to do to protect that machine. And then unfortunately, I say unfortunately, but when we talk about browsers, right, there is a very limited amount of stuff we can pull back from those HTTP headers and the requests that we're seeing. So really we can only see operating system and the version it's running. But versions, in all three of these scenarios, versioning of browsers can be a big thing. You don't want folks coming in with, an outdated version of Chrome or Firefox that may be vulnerable. And if any one of these checks and balances fails across, a posture perspective, we will present the user with a message saying, hey, you got a problem here. We'll also share them, give them resources on how to resolve, but we're also not allowing them to connect until they do so. there's a continuous check process that happens across these posture elements. So it's not just one time. We're going to go back and look at them every time they try to open up a new resource, make a new connection. And if anything changes, right, they turn off their disk encryption, they turn off their firewall, we're going to deny them access to your resources. So again, we can do this in ICE as well, right? We can do this as an ICE posture check and look even further in there. We don't have to leverage this, but again, this was a feature set that we had on the FTDs and the ASAs that we wanted to make sure we're still available to the overall platform if you're not utilizing something deep like ICE. And Intune, yep, yeah, great call out there. So, or Intune for that matter. A couple different things we want to talk about really quickly around applications and the publishing of these. I've talked about the idea that we'll create site-to-site tunnels, IPsec tunnels between secure access, your data center, and the clouds that they may be hosted in. But we also have this idea around a resource connector. And I mentioned this a couple slides ago, but I want to dive into this a little bit more. With resource connectors, we get a couple additional features and functionalities that we generally wouldn't have inside of a site-to-site tunnel. And a lot of this will leverage around the idea that in those clouds, you could have overlapping IP addresses. You could have AWS East 1, East 2, West 1, West 2, that all use the same IP addresses, but may use different resources, or you may publish different applications. With a resource connector, this is a VM that lives inside of these in those cloud environments, or technically ESXi in your data center. When we see a connection come in for a specific application that's behind a resource connector, we spin up a point-in-time tunnel. It's based off of APIs. When that connection is done, we tear that tunnel down. It's not persistent. And with that idea of overlapping IP addresses, because I'm saying applications 1, 2, and 3 live in East 1, and 4, 5, and 6 live in East 2, when I see that connection come in from the end user that's going to 4, 5, and 6, I will route them down through the resource connector into East 2, or West 2 for that matter, and not have to go into AWS, transit across those regions through your own resource, your own connectivity in the back end there. And again, give those users a better experience and a quicker access to that application. Something to call out with these, again, APIs, right, that are driven by this. We do need to place resource connector VMs inside of those environments. These actually scale out on throughput. I have a couple links in here on what that scaling looks like, but generally, when we talk about multiple gigabits per second, we will have a pretty large footprint inside of the AWS, Azure, and the VMware spaces. So there is a kind of tipping point here of when it becomes more cost prohibitive to use resource connectors versus VPN tunnels. But again, there's some instances here where I'm going to say the performance is going to be better to using a resource connector and an easier implementation, even with a little bit of increased cost of spinning these up. That it negates actually having the full IPsec tunnel. If there are questions and comments around these, we do have to do a little bit deeper dives around here. We have calculators that are published on our websites for secure access and the resource connectors themselves, so you can get an idea of what is anticipated in all the major cloud providers. But generally, we're talking each one of these resource connectors is 500 megabits per second. So if we have multiple gigabit of connectivity or need, we will have to have multiple resource connectors deployed to achieve that. Some things to talk about with resource connectors really quick, because we are creating technically holes in firewalls and where we need to create connectivity between secure access and these cloud environments. So just a quick little overview of what's needed. Again, it's nothing outside of 443 and 80. And we do publish all the URLs, as well as in there it says Cisco IP space. That's a very large list, so we don't specify that directly in here, but we do need some holes punched in the firewalls to make resource connectors work. So we've gone through and we've kind of chatted about end user connectivity. Traditionally, with a on-premise FTD, right? We hear a user come in. You hear a user come in. They say, "Hey, we're having connectivity issues." You're going to look at the FTD logs to try to determine what's happening. With a cloud-hosted solution, right? We're not giving you direct access to those FTDs, so we needed a way to come up with a visibility approach to show you what those end users are actually experiencing. And thankfully, Cisco purchased Thousand Eyes a couple years ago. And with secure access, we now have a full integration, as well as with any of the secure access platform, you get licensing for Thousand Eyes for what we call experience insights. And basically, what we're doing here is we're taking telemetry out of Thousand Eyes that says, "Hey, I've connected to secure access. I am, connected via Wi-Fi at home, and here's a bunch of stats and statistics around what that quality is like." So when a user calls in and says, "Hey, I'm having connectivity issues," we can actually launch the experience on insights to go out there and say, "Well, it's because you're not getting a great signal quality." And then that end user goes, "Well, it's because I'm sitting at the pool." Well, that's why, right? It's bad Wi-Fi. It's not a bad platform, right? We're not having issues in the platform here. We're actually having issues with the user. And again, we can extrapolate this out to, well, yeah, you're working at Starbucks. You're working in the Caribbean. You shouldn't be there. This application is actually the integration between Thousand Eyes and Secure Access is kind of letting that out and saying, "Hey, you're doing something that you probably shouldn't be doing." But again, really cool integration and gives us a lot of great troubleshooting points when users are calling in and saying, "I'm having connectivity issues." With the idea that we can do integration in the Thousand Eyes, we can also do application monitoring, right? We can the overall, how are we performing against AWS or to WebEx or to Microsoft Teams? We will give you those stats and statistics on what we know from a platform. Is someone having a problem, right? And then you can kind of help put those pieces of the puzzle together, saying, well, this user's trying to go to something in Azure. Azure's having an outage right now on the West Coast, and that's why you can give them the feedback. That's why you're seeing some latency here. So it's no longer, again, having to jump across multiple consoles or go to the internet down detector and stuff like that to try to figure out what's happening. We're going to show you that from an endpoint perspective with the integration of Thousand Eyes. And again, kind of just a little bit more deep dive into this. That example before showed some very high level telemetry, but with the integration of Thousand Eyes, we're pulling out things like CPU and memory. We're also going to, kind of rat out those users saying, "Hey, you're telling me you're hardwired. I'm showing you wireless connected, right? You need to be hardwired for this application to work or for this reason X, Y, and Z," as well as give you a bunch of details on the machine. From
Yeah, there's also the use case of like, Teams goes down, Outlook goes down, Netflix goes down, some other application that's going down, and you're not sure if it's the internet connection or if it's something with the CDN or if it's something with a outage happening with Microsoft or with Cisco. That it also helps with that type of business escalation, and you can give certain people those rights. So if you have your like level one who's able to look at this and kind of get more information before they move it up, rather calling the ISP or just saying, "Hey, listen, that's an outage. We'll keep you updated," like that type of stuff. It really helps correlate all that information.
So, Eric, I saw a message pop up that Tim fielded the question on from Paris too. Or I don't know if that needs to be addressed verbally. I didn't see the question.
Yeah, I think we're good.
Okay. Yeah, if we need to, we can obviously address that in the back end or after the fact. So we've talked a lot about the idea that we have this VPN connectivity, this ZTNA connectivity, but we never really have talked about the core aspect of and the core pieces of the overall secure access platform, which is Umbrella, right? We are looking at DNS traffic that is flowing through the entire process here, and one of the things that the Umbrella platform has evolved into is the idea that we are able to look at the full stream of packets that are coming through. We're understanding what those applications that the end users are trying to talk to are, and obviously with AI becoming more and more prevalent throughout everyday usage, there needs to be the ability to put some restraint onto that, some guardrails around that, some ability to actually look at what's happening and what those users are doing from an interaction perspective. So traditionally in the Umbrella platform, we had the ability to look at DLP, right? We had the ability to look at files that were being transferred. But the idea that the GPTs, the AIs of the world are real time, right? We're having to actually look at what those users are typing into those fields. And there has been many notable vulnerabilities, I say, of employees putting protected information into ChatGPT style products. With Umbrella and with Secure Access, we've built in those pieces of policy to limit as well as alert to when something happens when users are interacting with AI. Just recently, we brought in this. I'm going to skip one slide here. Just recently, we brought in this idea of guardrails, right? So when we see users interacting with an AI that are using certain keywords or certain strings that are proprietary to the businesses, we can actually prevent that from actually being sent to the AI all together, right? So we're not just going to give you a report saying, hey, this user uploaded X, Y, and Z document. We're actually going to stop that from actually getting there. And again, we have put in so many different pieces of AI controls into the Secure Access platform. First off, this is an AI powered platform. So we are looking at, from a threat perspective, what is happening across the platform. So we see a large number of connections. We see files that are being transferred that are of malicious intent. We are using our AIs to actually build a faster detection, more efficient remediation of those style events. But we've also brought in things like AI assistants. So, these are complex platforms. There's no two ways to say that any nicer than that. But with our AI assistants across all of our Cisco integrations, not just security, our goal is to reduce complexity in that, right? The ability to go in there and ask a question, am I seeing traffic from user one in this time frame, right? The AI system will come back and say yes or no. I mean, it will be more detailed than that, but very simplistically, yeah, we're seeing traffic. Here it is. And then as time goes forward, we're going to be integrating these AI assistants together so we can say, hey, did I see user two come in at 3 a.m.? And, if it comes back with a yes, we can go back and say, well, that's unacceptable. We actually need to lock this user account out. Where else has it touched in our environment? We've seen it in ICE. We've seen it, authenticate to wireless somewhere else. And then with automations, we can actually start driving SOAR style responses and saying, hey, go ahead and lock that AD account, kick it off the network, open up tickets for the service desk to go out and investigate, and not have to have people having eyes on glass 24/7 to try to determine what needs to be done. And then I talked about it very quickly around this DLP and the generative AI. How do we start limiting the user's interactions with that? Let them ask the easy questions. How do I do X, Y, and Z in Excel? But don't allow them to say, here's the Excel file I'm working on. How do I do this pivot table? So we actually have the abilities to go in there and say, hey, if we see certain keywords in these Excel files, or you can't upload Excel files at all, we will actually intercept that, and the AIs themselves will return back an error. It won't be very specific saying the organization has denied this, but it will be basically a block message saying it's been blocked for security reasons. And again, this now falls in this idea of AI guardrails. So again, in traditional DLP, we would have the ability to go in there and do real time inline, right? So as a user is interacting with a website, downloading files, uploading files for that matter, we had the ability to do an API connected out to Microsoft, so we can do a DLP at rest. So we can actually look at what's in the repositories they're interacting with and see if we find anything that's out of policy. But again, we layered in this idea of the guardrails. Every one of these DLP policies is 100% customizable. We come out and we lay out a bunch of templated ones that we feel, from a HIPAA, from a PII perspective, that will look for social security numbers, look for credit cards. But then we actually give you the ability to create your own. So if there's a certain string or character set for an account number you guys utilize, or there is proprietary company information or tags that would be sent from your current file structure, we can look for all that. And you can customize what that is of value for your organization, and then create rules around it. Whether it's, hey, we just want to monitor this, we want to log it, or we just want to step in and block it entirely. Some things, some additional pieces around this idea of protecting with AI, right? Kind of talked about these high level in the other couple slides here, but right, we are extending our reach into the AI apps. Right now, we're publishing or have integrations with over 70 of them. We do have the ability to include additional APIs. And again, this gives you a better understanding of what the threat visibility is, where data may be leaking out, and also how to lock down when we see users starting to access additional AI capabilities or new chat GPT type integrations. And this is kind of a high level example of all these, but I want to call out the fact that in this slide, I don't have the example up here, but when DeepSeek came out a couple months ago, and everyone started freaking out because people are starting to use this, Cisco and our Talos intelligence group already had controls for this. While it was major news that DeepSeek was out, it wasn't major news to the threat intel community because it was already in testing, right? It was major news because it was the first day it was out there and everyone was utilizing it, and it drove NVIDIA stock price down because of how much faster it is. But the reality is that that unfortunately that's still a Chinese controlled application, or it's anticipated it is, and the threat intel community already knew about it. So we already had protections built into our umbrella platforms and secure access platform to mitigate that, to reduce that risk and actually block the users from getting access to it well before it became mainstream news. So what I'm getting at there is, as the news cycle picks up on these new AI capabilities, we're actually a couple steps ahead of them, and you will have the controls inside of secure access as well as umbrella to mitigate those, block them, and make sure that if you are seeing users utilizing them, you can refer them to whatever internal group you want to go and do a deeper dive. If that's, you shouldn't be doing this, send them to HR, send them to legal. If it's policy and compliance, send them over there and make sure that someone reviews what these users were doing.
Or simply being able to communicate to your C-suite, yes, we know about DeepSeek and we have controls around it, even though it was last week.
Exactly. Great call out there. So I got, I think, 2 more slides here. Kind of in closing with this, if everyone on the call is not aware of Talos Threat Intelligence, the group that actually drives all of our intelligence across all of our security platforms, I just want to do a couple call outs for them. This is a group of folks that is 400 plus deep at this point. Apparently there is a timer on that one. Sorry about that. There's about 400 people in the group. They are seeing massive amounts of data across the internet. A lot of that is with the integrations that customers are utilizing from us. You are sharing telemetry back to us, and based on that, right, we are updating these blocks. We are updating these threats in real time. Again, apology for that. Going ahead. So when a new threat is seen, it is being pushed out to the platform immediately. We're not having to wait for updates. We're not having to wait for patches to roll out, hopefully. Again, one of the things to call out here with Talos is not something that you as a customer can purchase. It is something you consume through all of the Cisco portfolio. And I think that's what makes it a differentiator for us. A lot of people would love to just buy Talos Threat Intelligence, but unfortunately you can't. You consume it through all the products. It doesn't have a cost to it because it's part of the overall platforms. So in talking futures and talking where we're headed with secure access itself, there's 3 different kind of pillars we're working in and trying to evolve. That's the idea of trusted identity, right? Making this more seamless so that when we understand a end user, we understand an endpoint, we can trust that for a certain period of time or until a scoring in the backend system changes. So They've installed an application, their username has changed, their password has changed, they've moved geographically. We will step up the posture assessments, the overall risk scoring. And if things get out of control, we will just deny them access to the platform. So if they've moved around the country, faster than you can from on an airplane perspective, we're not going to allow them to access the platform.
Isn't that called the Superman theory?
Yeah, that's one of them. And again, because of that, and how we're doing that is through continuous assessment, right? We aren't just looking at you when you log in at 8 a.m. and saying goodbye to you at 5 p.m. We're looking at you at multiple intervals throughout the day as you change applications, as maybe if you do change geographic regions, right? It's not impossible to go from Eastern Standard to Central within a couple hours, right? So we're constantly doing this continuous assessment to you. And if anything changes inside of that, again, we will start to reduce your access. We may prompt you for more MFA. We may prompt you or restrict you from VPN and only allow you into web hosted applications. And again, the idea that with building off a trusted identity and continuous access, we're now adapting that. So again, as the risk score changes, as you move around, if we need to, we're going to stop you from accessing the network.
Thanks so much. Oh, go ahead.
Yeah, and so again, a couple key things with secure access itself. Our main goal is to allow access from a myriad of style devices to a myriad style of services, right? From anything to anywhere. But in the middle of that, we need to make sure it's safer. It's easier for IT to pull telemetry out of and understand what users are doing. And then lastly, again, we're trying to enhance this end user experience. We're trying to make it very seamless for them, whether they're on or off your physical network. And with secure access, leveraging things like zero trust network access, leveraging traditional IPsec tunnels, we do feel that we have an upper hand in this solution to achieve all of this. So I think I'm actually up to the minute on time here. Yep. I will end with this really quickly. Also, with secure access, as the meeting was starting, I saw a bunch of names and folks that I knew. You've seen some of these pitches before. We do have live demos of this. We do have live workshops of this where you, as an end user, can actually go in there and build policy and interact with the platform itself without deploying it into your environment. If we're well beyond that and we actually want to start deployment, we do have full POVs and POCs available. We do have certain criteria that we want to try to achieve with use cases inside of that. So it's not just kind of an open-ended. And we will be doing a couple events here in the next couple of months around secure access. We will get those out via email, as well as I'm pretty sure everyone that's probably on this call has seen our invites for our Philly Live Roadshow, May 15th. That is being hosted at the Philly Live Casino. It is 100% security talk that we're doing. There will be the rest of the portfolio partnering with us. We will have a distinguished speaker from our business group there to talk security with us, as well as myself and a few others there to demo and have a little bit deeper conversations. And
he's also a principal engineer, not just a distinguished speaker.
I didn't want to let the cat out of the bag yet.
Yeah.
We will have a principal engineer from our security business group there.
So that's kind of the aim for a lot of this, is to try to make it more technical so that you can actually feel like you're getting value from it and understanding what it needs to be, rather than it being just a noise or the same elevator pitch that you've heard over and over. So I do hope y'all found that helpful, and we're going to do a lot more of this. Next month, we're going to be doing a session on AI and what that means, and we'll have somebody from our new AI team that's going to come out and speak on that. So I'll have more information soon, mainly because I kind of just told him to do whatever he wants. Because we do want to keep this casual. We do want to keep this open. And if you want to email us, hit us up on the side to talk about something more, we can do that as well. This is being recorded, so for those who do have to get out, I understand. But for the recording, I'm going to make a few announcements just so that everybody has them. One is Cisco Live. We have that registration. I think there's a comment as well. but for the May 15th event, I believe. But yeah, I'll get right on that. So we have Cisco Live June 8th through the 12th in San Diego. Registration is open. I think we are still at standard. Yeah, we're still at standard. So there's still time for the price goes up. You can use Cisco Learning credits. They will not be used for the hotel and flight, but you can use them for the um, actual event and tickets. So if you have any questions on how many CLCs you have, reach out to your SE. They can help you out. I will be there as well. So if you want to meet up for happy hour or dinner, let me know. And then this is our YouTube channel, so we'll have this updated to that as well. So if you missed anything, or if you want to send this to one of your peers, please let them know. And then let me move this. And this is our website. We're still working on this. This is our Philadelphia Select website. And I'll send this stuff out, and you should have something come automatically to you via email afterwards. And this is that Philly Live Roadshow event that he was talking about as well. Thanks for the plug. And that is all I have. So I'll stop the recording.